So let's get started with LLD or low level design. Now this is extremely important when it comes to software engineering. Now this is just not for interviews. Please do not do it just for interviews, because if you're someone who's into writing code, this is going to be extremely important. Let me explain you in naive terms what is low level design. Again, this is going to be an introduction video, so I'll be talking about everything on a surface level, and eventually we will be diving deep as we move into the playlist. So first of all, okay, what is low level design? Like, why should a software engineer who is into writing code learn it? Imagine you have a code base which has a lot of code, and suddenly one day something breaks, and you're not able to find it. Why? Because you have written code, but you haven't followed any design principles. That is why it becomes extremely difficult to debug in that code and to figure out where is the issue. So this is why you should be following certain design principles, so that it becomes easier for you, for anyone who is new, to read that code, to figure out what's breaking, and to scale it up as well. Tomorrow, if I'm adding a new feature and I'm new to the code base, again, if it's just written for the sake of just writing it, I'm gonna find it tough to integrate a new feature as well. So if you're writing code, you want your code base to be scalable, to be maintainable, and to be reliable at the same time. That is why you should be following design principles, and that is what we will be learning in low level design. So throughout the playlist, my focus will be to make sure that your fundamentals are absolutely clear, and at the same time, if you're preparing for interviews, we will be covering up a lot of interview questions so that you're interview ready as well. So this is an introduction video, and you must have a question. Hey, what are the prerequisites for starting with LLD? First of all, please make sure that you go back and watch my object oriented programming module. You might be thinking, hey, we already know about it. Trust me, please go back and watch my object oriented programming module. There are a bunch of things that I've covered which is something you might not be knowing. So please go back and complete it. If you have done that, then only start with this particular one. Perfect. Who should start? Like, who should be learning low level design? If you're a first year or a second year, do not touch it. Just do not touch it if you're not done with DS Algo. If you're done with DS Algo, you can get started with LLD. Beyond second year, third year, fourth years, if you're preparing for interviews, SD1, SD2, SD3 senior engineers, absolutely yes, this is extremely important. If you're someone who is writing code, if you're someone who's designing as well, this is important for you. Next one, hey, which language will you be using? Obviously, I'll be teaching in English throughout, and at the same time, I'll be writing code in Java. Now, you might have a question, hey, Striver, why Java? So typically, the concepts are same. If I write in Java, it doesn't matter, because you'll have to focus on concepts, right? I cannot teach with multiple languages at a time. That will make the video longer, and that will confuse you as well, right? We have a Java basics video attached in object oriented programming module. Please go back and watch it. If you do not know, all you need to know is basics of Java. And after that, you can understand the design principles. The concepts are same in C++, the concepts are same in Python, and in any other object-oriented programming language, the concepts are same. So focus on, grabbing the concepts. Language is just a syntax-based thing. Once you understand the concepts, you can literally write code in any of the language that you use. So do not stress much on the language that I'll be using. Focus on grabbing the concepts that I'll be giving you. Perfect. And why Java? Because, majority of the code bases, specifically of the bigger MNCs, are in Java. So most of the interviews that you will be giving, the interviewers will be comfortable somehow in Java. So that is why I usually prefer Java, despite me being someone who's, into C++ when I was doing CP or competitive programming during my college days. What after this? Once I've done this low level design playlist, what should I do, to understand more or get into more depth? I'll be covering this in absolute depth. But if you're preparing for interviews, what I'll recommend you to do is, read through interview experiences, design much more systems, get into it, because this is a subjective topic. I can teach you, 40 topics, but you can still do 100. So if you are not confident, I'll ask you to do more and more design stuff. Pick up any system and try designing it. That is what I'll recommend you to do after this particular playlist. Perfect. So we are done with the first question that we had in our mind. Next question. Hey, what is the formal definition? You told us a definition, but again, what is a formal definition of low-level design? Let's understand. Now, low-level design is nothing but where a code starts to take shape. For an example, I'm building a website and I'm saying that, okay, I'm going to implement the authentication, which means it's going to do the login, the sign up, and everything else. So I'm just using a word, authentication. But the moment I get into details, okay, what kind of classes will I be writing? What kind of interfaces will I be using? So that is what we call as designing. So the formal definition is where your code starts to take shape in forms of classes, variables, interfaces, and all the other concepts that we did learn in object-oriented programming. It's the bridge between the architecture and the actual implementation. A lot of times, in the high-level design, we do the design, but on a very, very high level. Whenever we are picking up a certain component, let's say authentication for that reason, and when we get into that, that's when we term it as low-level design. Understood the formal definition? Let me give you a real-life example so that you can relate with high-level design and a low-level design. Imagine you're buying a 3 BHK apartment. Typically, on a higher level, I'll tell you that a 3 BHK apartment will have 3 bedrooms, 1 living room, 1 kitchen, or maybe 2 bathrooms, right? That is what I'll define you. Now, this is something which is a high-level design. What is the low-level design? Now, when I get into a certain bedroom and I say that, okay, this will have a bed in that corner, this will have a study table, this will have a TV, this will have a sofa, etc. This is what we term as low-level design. When we get into details, extreme details, that is when we term it as a low-level design. Again, it's part of system design. System design can be classified into high-level design. High-level design is 3 BHK, and low-level design is, okay, a bed, a TV, you get it, correct? Perfect. So we know about a real life example as well. Can I get a coding example? Obviously, you can. As I said, authentication. So whenever we are talking about authentication, what do we need to maintain? We definitely need to maintain something like a login, something like a sign up, at the same time something like a forget password. So maybe while designing, we'll have a login class, maybe we'll have a sign up class, maybe we'll have something around something else that is an edge case. So this is where you get into depth and you decide the classes, you decide the variables, and you decide every layer that you will be defining. And this is what we will be doing while we will be learning design principles. Again, this is a very surface level example. It's not necessary that you will have a login class. I'm just explaining you in terms of coding. Understood? Perfect. What are the key characteristics of low-level design? Like, how do I understand that, okay, we are getting into low-level design? First of all, we'll have to make sure that the code is granular and it's on the code level. That means whenever you're writing code on a granular level, even if you're writing a class name and you're defining what the class does, that is when we are getting into low-level design. It is not on a surface level. It's getting into the depth. Okay, this is my class and the functionality of this class is to do so and so. So that is a granular and a code level. So that is the characteristics of low-level design. What is the next? Implementation focused. What is the class doing? What kind of functions does it have? What is each and every function doing? So you're defining literally the details. That is when we're saying that we are into Low-level design applies object-oriented programming principles, encapsulation, abstraction, inheritance, and all the other object-oriented programming principles we have learned. If we are applying them, then we are getting into low-level design. So again, this is a formal definition. We'll be getting into that when we'll be designing, like whenever we will be designing a lot of systems, you'll understand how we do that. Perfect. So we know about the formal definition. What is the next thing? Hey, what is HLD and what is LLD? Let's understand that. So imagine we have a code judge in TUF Plus, isn't it? So if I have to do a high level design, can I say that on a front end, we do have a couple of buttons. One is the run button, while the other one is the submit button. Typically, these two buttons are responsible for running your code. Agreed? So this is what we have on the front end. Whenever you press the run or the submit button, what happens is there's a request that goes to the backend, correct? And the backend basically takes your code, understands the language, or takes the code and takes the language that you're using along with test cases if needed. The backend is going to run it, correct? So typically we have a judge which runs it, and once the judge has executed it, it will be returning a response. And the backend will be maybe storing the response in the database that this is the submission, this was the result, this is the code, this is the language, this is the time. It's going to store everything in the database. And once we are done, the backend is going to send back the response. And this is what we call as HLD. And this is a very, very simple definition, like very, very simple HLD that we have done for an online judge. This definitely has multiple other things. You can introduce authentication in between. You can introduce a lot of other things as well. But again, I just want to keep it simple so that I can explain you the definition of low-level design and like the difference between HLD and LLD. So this is HLD. Now what is low-level design? Typically, the low-level design is in the backend, whenever the run is hit, whenever the submit is being hit, what are you doing? So maybe you do have a run class, maybe you have a submit class, and then on the judge side, maybe you're executing something, so maybe an execution class or something around that. Maybe something like a CPP class, maybe a Java class, maybe a Python class. Again, that is low-level design. When you get into details and you say that in your backend, you have a run class. Inside run, what do you have? You define the variables. Inside submit, what do you have? You define the variables. That is when you get in, like whenever you get into it, that is when we define it as low-level design. We are getting into it. So for every system, you will have small components. And for every component, you will have a design into it. And that is what we term as low-level design. HLD is a lot of components, but LLD typically focuses on single component and designs it in depth so that it is scalable, maintainable, and reliable at the same time. Understood? Perfect. Let me get back. Now we know the difference between HLD and LLD on a higher level. So what is the next question? Hey, who are the stakeholders when we are talking about low-level design? Like, who does it? Is it a fresher who does it? Typically, in an industry, it varies. If you're in a startup, let's say, if you're in a startup like Take You Forward, which is, we have like 5 or 6 people in engineering team. Over here, I do most of the designs, or someone who's into, like someone who's an experienced dev will be doing all the design, and someone who has recently joined will be writing the code. So the stakeholders are typically the senior most members. It could be managers, it could be your tech lead, it could be your some high level, architecture guy. Generally it is the senior level people. Typically, if you're a fresher, you will be asked to implement. And that is when you can pick up, okay, this is how they're designing it. And eventually, when you have experience, there will be a point where you'll start designing smaller components. And as you grow in experience, you'll be designing bigger chunk of components as well. So that is about stakeholders. Why is LLD important? So I'll scroll it across, and there are certain things that you'll have to keep in mind. It does avoid a lot of rework. Now imagine there is a lot of code which is being used at multiple places. Same code being used at multiple places. So if you can design your system in such a way that that same code that was being used at multiple places is at a single place and everyone else is using it. So that will avoid rework, because tomorrow, if you're writing a code that requires the same code, you can literally reuse it. So it avoids a lot of rework if you're designing it properly. But if you're not designing it properly, then you'll have to write the same code again, which is rework, right? You're writing the same code again and again. I know it's copy paste, but you're still doing a lot of rework. It improves collaboration. Now, what do we mean by collaboration? Imagine, like, as of now, you write very limited code. So let me explain you. There is a team A and there's a team B. The team A is responsible for component 1. The team B is responsible for component 2, right? And the team A is building a feature where you'll have to take help from team B. Now, if their code is following design principles, if it is structured properly, the team A can reach out to team B, and the team B will do very limited modifications in order to allow the component 1 that you're building to use some portion of the code in component 2. But if you're not following design principles, the collaboration might become difficult. When the team A reaches out to team B, they might say, hey, it's going to be very difficult. It's going to take a lot of time because we'll have to do a lot of changes in our code base for you to use it. So maybe you should be building your own. So if your code is following design principles, if it is written in a clean manner, then the collaboration becomes very simple. You will be able to collaborate across teams, across components. You will be able to reuse some of the algorithms which is being written somewhere else. So collaboration is improved, and that eventually saves a lot of time. Got it? Promotes scalability. Obviously, if your code base is not written properly, what will happen is whenever you are building new features or whenever you are sunsetting features, sunsetting means you're throwing off features because it's not being used by the users. So in both the cases, it becomes difficult, because if you are introducing a new feature in that huge code base to insert it, it's going to be difficult because you'll have to take care that the other portion of the code doesn't break and all the other things. Similarly, if you're sunsetting the feature, you'll have to make sure that everything else is working fine. But if you have designed it, if you have modularized your code, sunsetting a feature or introducing a new feature becomes extremely easy, and your code becomes scalable as well. Got it? Encourages best practices. Why is this important? Imagine today you're working and you're writing a lot of code, and today you leave your company. Tomorrow someone else will be joining. Now for him to understand, he should be knowing, okay, what kind of things you have done, right? So if you're following the best practices, he's aware of the design patterns typically used in the industry, and he'll be able to read through the code. But if you have written crap code, it's going to be extremely difficult for that code to be readable by someone who is new to that code base. So that is why it's very important that you follow the best practices so that the code can be easily readable, and at the same time you can always maintain and rely and scale the same code. So that is why low level design is extremely important. Now when I talk about low level design, if you're a startup, like for an example, take you forward. When we started writing code specifically in TUF Plus, did we follow low level design? Not that much. We were following a lot of modular or object oriented programming practices, but not on design principles level. We were following a lot of object oriented programming principles, but not the design principles. Why? Because over there the priority was to ship the product. So sometimes you'll have to prioritize. It's not important that you always follow all the design principles. it depends on the situation. Like for us, whenever we were launching TVF Plus, the focus one was to ship the product, right? So we had to kind of just skip a lot of best practices. But now when the product is stable, our team is working on getting it fixed. Why? Because we know this is going to scale, and whenever it scales, it's going to break. So it's very important that we fix it as of now. The code base is not that humongous. We can fix it as of now. So this call is usually taken by higher stakeholder people, that okay, should we follow a lot of design principles, or should we skip some of them in order to get it shipped faster? Again, everything, like all of these things sound really good on pen and paper, but when it comes to implementation, there are a bunch of other things that have to be considered as well. So that was about the introduction video about low level design. I hope you have understood what is low level design, again on a surface level, but eventually when we get into this particular playlist, it will be real fun. Again, thank you so much for watching. The notes are there, you can read through them as well.